So hello, at my today's presentation, serverless automated test of web apps in cloud world. And just a few words about me. I'm Tomasz Konieczn. I currently work for Raw, one of the New York-based startups, as senior QA engineer. And during my career as a QA, I did very different things. I worked at very different areas, but most of them were related to test automation. So test automation itself, test infrastructure, architecture. I also worked for a year and a half as a DevOps engineer, so Docker, Kubernetes, AWS, Linux, and things like that. And today's presentation will be related to both of these areas, I mean test automation and infrastructure. So let's start with a basic question. Why do we execute end-to-end regression tests? Or maybe why do we even execute regression tests? Because during the development of new functionalities, it's possible that we'll introduce bugs to already finished ones. And that's why we execute regression tests, because they can show us possible problems. But why do we need end-to-end regression tests, I mean high-level ones? Because only high-level tests can actually guarantee us that something is working. I mean, if we have, for example, low-level tests like API tests, and one of the API tests is red, well, that's quite obvious. Something is wrong with application or the test itself. But when all of the low-level tests are green, it only means that these tests are green. I mean that they can guarantee us that something is actually working. That's why we need high-level tests. But there is one serious problem with them, I mean time. They are really slow. And it's not only about the time of QAs or whole development team that they have to spend on the execution of these tests. It's also about feedback time. I mean, how long do we have to wait to get the results of these tests? And the solution for that is automation. If we automate something that's repetitive, and regression tests definitely are, because we have to repeat them again and again during development process, then we can definitely save time on this execution. But the second part is that automation can also reduce the execution time, because basically automated tests can be way faster than manual ones. Computers can click way faster than humans. But I think we should think more about execution speed. It's more about execution speed. Because faster execution of tests means faster feedback. We will know earlier in development process if the application is working correctly or if there are any problems. We'll be able to fix these problems earlier in development process, where the cost of fixing them is way lower. And also, faster feedback means faster delivery. We will be able to actually deliver faster because of that. I mean, we will have better predictability early in the development process. We will deliver faster. And this should be our goal, I mean, delivering business value. So regression tests are really related to business value. And that's also why we automate tests. There are multiple benefits of that. We can execute them way faster than manual ones. I mean, at a few minutes, maybe even instead of hours. If we have automated build process, some CI server, for example, and we include these automated tests in our build process, then we will get feedback even faster. I mean, after every pull request, after every repository push. So that the feedback will be way faster in this case. And if we have significant test coverage, we can even think about CD, I mean continuous delivery or even continuous deployment. Because we have that as automated, we can easily verify if application is actually working, and we can depend on it. We can make decisions, even business decisions based on that. It's great, isn't it? Well, then the test set grows. I mean, we develop application, it becomes more and more complex, and the same happens to our automated tests. So we have to implement more and more of these tests, and the test set becomes bigger. So execution time increases again. I mean, 10 minutes, maybe 30 minutes, even hours. That's definitely too long if we want to execute them every pull request, every repository push. It's just not possible in this case anymore. So we have exactly the same problem that we had earlier before we started test automation. So tests aren't fast anymore. We have to do something with this. So I think it's best to show you some example. Let's assume we have 500 Selenium tests. Execution of each of them lasts about 20 seconds. So we need about 3 hours to execute whole set. It's definitely really long time. Well, it may be far better than the manual tests still, but it's too long and to wait for the results. So how to solve these problems this time, as we already have the tests automated? Well, we may think about test set redesign. Maybe we don't need to execute whole full set every time that we run tests. Maybe we can introduce some smaller test sets that will be executed, for example, at pull requests, and we will only run the full test set at specific events, for example, merge to master branch or before releases. Maybe that will be enough. Or maybe we should think more about test pyramid. I mean, maybe we can replace some of these high-level tests with low-level ones. They are way faster. Maybe we should do this. Maybe we can do this. But what if we already did that and tests still aren't fast enough? And we can replace all high-level tests with low-level ones, because only high-level tests can actually guarantee us that it's working. So maybe less frequent builds instead of running tests every time we push something to our repository or at pull request. Maybe we should run tests just a few times a day. Maybe it would be enough to execute tests every, for example, a few hours. Or maybe more compute resources. I mean, instead of running one session at the same time, one browser instance, maybe we can run a few, like 4. We can run, for example, 4 virtual machines, run tests there. We will run tests in parallel. We'll speed it up like 4 times. But in real life, it won't be like 4 times. Sometimes you will have like a few concurrent builds, so we will need 4 builds multiplied by, for example, 5 builds that we have to run at the same time. So we will need like 20 instances. Sometimes we won't have any builds, and we will keep these resources unused. It can be quite expensive. So maybe you should think about some infrastructure scaling, maybe some clusters. That's what I used like a few years ago. I used Kubernetes cluster to create test infrastructure, so it scaled up and down depending on the usage. So when we needed like 5 builds at the same time, it scaled up, then it scaled down after the builds. And it worked, but it definitely wasn't a good solution because it was quite complex. I mean, it was both quite complex to implement and also to maintain. And there was lack of understanding of this setup in a team, and I think it's a very important part. So my answer to all of these questions will be just no, because these solutions aren't solutions at all. They are like basic workarounds, and no, that's not the thing we should do. I mean, we have to think about test pyramid and the rest of the things, but it's not really a solution for these problems when tests are too slow. In my opinion, the real solution is cloud. And the really important thing here is to use cloud properly. So not again the same virtual machines again and again. I mean using cloud properly, services that can be really useful in a specific case. And in this case, I mean, if we have 500 Selenium tests, definitely we should go with parallel test execution. It should be our goal, because that's the only option to really reduce the execution time. But I'm not saying like 4 instances or maybe even 8, because it will reduce the execution time from 3 hours to like maybe 40 minutes, maybe something like that. It's really not that different. I mean, we won't be able to wait like 40 minutes to get the results of our tests if we want to merge a pull request. So here, if I am saying about parallel test execution, I mean like hundreds of concurrently running tests, because that's the only option that can really help us speed up the execution. And if we want to implement something that's at the same time quite easy to maintain and also implement, then we can go with serverless services. So functions, because we have our code, we have our tests. The only thing that we want to do is to just execute the code, get the results. And that's what serverless or function services allow us to do. I mean, we can deploy any code that we want. We can trigger the function, get the results. That's all we want and need. And in this case, I used AWS Lambda. It's possible to use different cloud providers, but I used AWS for most of the time, so that's why I used it. If you don't know Lambda, it's the serverless function service at AWS. It allows to deploy code in one of the supported languages, so that's Python, Node, Java, and a few others. and just trigger the function, get the results from this code. So idea is really simple. And the best thing here is that we don't have to care about infrastructure. We don't have to think about scaling. It's all already available there. So what's also great about Lambda is the initial concurrency. We can deploy our code, trigger it like 500 times just after the deployment, and we will get 500 results, or maybe even 3,000 results depending on the region. Because depending on the region, we can trigger from 500 to 3,000 functions just after the deployment. So that's the concurrency we need here. And also, AWS introduced functionality named Lambda layers like a year or 2 years ago. Lambda layers allows us to create custom runtime environments because we will use Lambda for specific language. For example, if you have a test in Python, then we will use Lambda for Python. But we'll also have some external dependencies that we use. For example, Selenium libraries, or we will have to deploy also browser to this function, so we will have browser available, like for example Chrome. And what Lambda layers allows us to do is to deploy it separately from the code. So we won't need to deploy everything every time we want to trigger the new function. We'll be able to create custom runtime environment where we will have all libraries that we use in our tests and also the browser. So in this case, I used Serverless framework that allows to easily manage the functions because it's the implementation of infrastructure as code concept. So we can describe whole infrastructure and code. I mean, not only function, but also all other services that we use. So for example, DynamoDB or S3 bucket or anything else that we need for our function. I used it with AWS Lambda. So start the implementation. First, I will describe Lambda layers because these are other dependencies that we need. So we definitely need browser. In this case, I used Chrome because that's the most popular one. So we will have Lambda layers directory where we will have all of our binaries or dependencies. Then in Chrome directory, we have 2 binaries. The first one is Chrome driver, because we need Chrome driver in the case of Selenium, and we also have a Chrome or Chromium browser. We also have the second directory, that's the Selenium in this case, and I named it Selenium because here we have all of other dependencies that we use in our tests, so it will be Selenium library and other dependencies. I just pip installed it to the specific directory, so it's very easy to prepare this package. And also we have here serverless YAML file, that's the description of our infrastructure or at least layers part. So that's the serverless YAML file. We have a service here, so that's the name of our specific service, in this case Lambda Selenium layer, so all our layers that we need for our test to run. Provider, so in this case AWS, runtime that we will use in the case of Lambda, so Python 3.7. That's the Lambda type that we will use because we want to execute Python code. Region, Europe West 1, timeout, that would be enough because we have the tests last like 20 seconds each. And also definition of our layers, so that 2 layers will be created here, Selenium with our dependencies and Chrome. And everything that's in specific directories or Selenium or Chrome will be available there and a layer will be created from it. But there are limits in case of Lambda. I mean, like half a year ago, I was possible to just put Chrome browser there, deploy the function, and it was working. Currently, it's not that easy because because Chrome browser is heavier than earlier, and it's not possible to upload it directly. So even if we use Lambda layers where we can put up to 250 megabytes, it won't fit there. It's heavier. So that's the one additional thing that we have to do. The solution for that is to compress it before deployment. So instead of deploying a layer with browser, we will deploy compressed browser binary there. Because during the execution of Lambda function, we can use a TMP directory for any temporary storage we need. So the idea is to decompress it at runtime to this specific directory. So we will be able to fit our browser binary into Lambda layer. We'll be able to deploy this Lambda function, and at runtime we will decompress it. So it's really important here to select the algorithm, the compression algorithm that's really fast in decompression. We also have to think about compression rate because it's also important here. It has to fit in the specific allowed size. And I found two algorithms that are really great here, XZ or ZMA, or broadly. We don't care here about compression time because we will deploy it when, for example, new browser version is released, so that's not that often. But the compression time is really important here. So in both of these cases, it takes about a second to decompress whole browser binary at Lambda function, and I'm basically doing it every time I deploy new function. TMP directory is shared between different functions, so the first execution will do it, and we don't have to repeat it again and again. But we have to think to also include this one in our function. So before we will start actually using browser, we'll have to extract our dependencies. So not only Chrome, but also, for example, Chrome driver, if we'll need to compress this one too. The code is really easy here. I used XZ in this case, just a tar.xz file. It will be extracted from opt directory where all of the Lambda layers are copied to the TMP directory. Then we have to create our function. That's the code that will be actually executed there. That's the proof of concept, so I really simplified this one, so we don't have all of these test files here. We don't have page object because it would just make it less readable here. We have only one file handler here. That's our code. In a normal case, we will deploy all other tests here. And we also have the serverless YAML file. That's a definition of our infrastructure, function. So here we have service, Lambda test runner. That's the name of our service that will be executed there. We have a provider, so again, AWS, Python 3.7 as runtime. Memory size, here we have the RAM size that will be available at our function. We can use up to 3 gigs of RAM. Timeout, 30 seconds. That will be enough in case of our tests because each of them executes in about 20 seconds. And we also have the definition of our function. So function named Lambda runner. We have handler, so that's the function in the file that will be actually executed. So in handler Python file, we have the Lambda runner function. It will be triggered if we trigger our Lambda. We also have layers. So we created layers earlier. We have to connect it with our function, so it's available there. So we are just using CloudFormation IDs here. So both Selenium and Chrome layers will be available at our function. Now the handler file, that's the code that will be actually executed. I skipped the decompression part because I showed it earlier. So we have standard Selenium part here. So we import WebDriver, browser options. We also have JSON to create the response. Then we have our function that will be executed, so Lambda runner, and that's standard for Lambda. We have event and context here. We can pass parameters from for example, runner to this specific function. We extract the dependency, so in this case, Chrome tar.xz, because we need browser to be able to execute it. Test the result, so that's for a result storage for specific function. Then we have browser options. We extracted our browser binary to the TMP directory, so we have to set it to the specific directory. Options, so we definitely need headless because we don't have any graphical user interface there. We definitely need this headless option. And we also definitely need to disable dev SHM usage. That's the shared mem. We are not able to use this option in case of Lambda. We have to disable it. Single process and no sandbox aren't needed, but are useful if we want to improve the performance. So that's why they're also used. And we also have our browser driver here. So it's an opt directory. It's copied directly from the layer there, so we can just use it. We don't have to compress and decompress it because it's not that heavy. Now we would have the actual test. I skipped this part because it's just the Selenium. Everyone knows this part. We can print anything here to the CLI. It will be logged in our function. It will be available in our logs. And then we just return the results. It's really simplified here because it's just a proof of concept to show you the idea. But that's how it works. And in normal case, we will have here all of our test code. I mean, we will deploy all our tests that we have, whole test set, and we will just pass as a parameter which one should be executed. So we will, for example, pass the test case ID that the test, for example, number 1 should be executed in specific function. And it will be implemented in the runner side. So now the runner, that's the code that will actually run or trigger our functions and gather the results. So here we have the Boto3 library, that's the official AWS SDK. ArcParse for just parsing arguments, YAML, JSON, and base64 to create the response, to parse the, to create a request, parse the response, and also Python concurrent futures, thread pool executor, that's for concurrent execution, because we want to trigger all of this tests at the same time. Arguments are very simplified here. We just have the verbose mode for more detailed logs, and we also have the ability to disable parallel mode if we want to compare it with a standard run. Very simplified because it's proof of concept. Then we will have to load our data. So we have a testset YAML file where we have all of our tests described. So for example, we have test case 1, 2, 3, etc. there. And based on that, we can trigger specific ones. So we load this to YAML data, then we create the data dictionary that will store our test states. So is it scheduled or is it executed? What's the result? What's the output? So for example, Selenium output here, we will add it to every specific test case ID. So we will have a huge map where we can track our test execution states. And then we will define our Lambda function, access keys, settings, etc. So AWS access key, secret, region, our function, etc. And then our invoke test method that will actually invoke specific Lambda specific test. So in this case, we can pass test case ID parameter here. So based on that, it will execute specific. It will execute one function with specific test case there. So it will mark the test case as scheduled. So it will be triggered. Then it will actually invoke our function. So Lambda test runner function, invocation type request response. That's a really simple one because we can just make the request, wait for the response, and we will get it here. We don't have to track it in any way. A payload, that's how we can pass arguments to the Lambda function. So in this case, we will pass this test case ID parameter, so the function will know what test should be executed there. Then we, after the execution, we will mark this test as executed, and also we'll save the output from the execution. We'll parse everything, save the results, and that's how the specific function is triggered. Now how we will trigger all of this? Well, I just used this thread pool executor to run all of this as threads locally. So this thread pool executor will create up to 500 workers. Each of them will execute this invoke test method. So it will just execute 500 times this method every time with specific test case ID. So single Lambda will execute just a single test case from this 500. There's also the option to run it in sequential mode here. So we can check, for example, what's the time difference just for the test. And then we have our report. So we have some human readable information about the test execution. So how we create stats, how many we check how many tests passed, failed. We save the we print the output if the test failed, or for every specific one if we have the verbose mode enabled, and then we print summary. So we have just the human readable info, how many tests passed, failed, and yeah. So let's try to run this set. This time I ran only 5 test cases to simplify it a bit, because if I would run like 500 here, the output won't be that readable. So we can see that test case 1, 2, and etc. are scheduled, then they are executed. The order is different here because every function will finish the execution in slightly different time. Then we have reports, so it's ordered here, and we have a summary. 5 tests passed, none of them failed. And we have, because I ran the time command also, so we have statistics for this Python .py command. We can see the execution time, so it's 25 seconds to execute it. It took 25 seconds. So instead of 20 seconds multiplied by 5, we have 25 seconds here. It's a bit better. But what about full test set? I mean, I told you that we have like 500 tests, and then I ran 5. Well, execution of 500 test cases took about 30 seconds. So we reduced execution time from almost 3 hours to about 30 seconds. If we add deployment time, it will be like 35, maybe 40 seconds to execute the whole set. So it's a really significant reduction of the execution time. But what about the execution cost? Because, well, we just ran like 500 Lambda functions at the same time, concurrently. Well, it's about 17 cents. I calculated it for the specific case. So I think it's really low if we think about development cost. I mean, we don't have to think that long to get the results. We can make decisions based on that. We can run tests early in the development process more frequently. We'll know about possible bugs earlier. So I think that overall cost of development is way higher in comparison to running this every like 10 minutes, for example, or 15 minutes if we need. And what's also great about it is this proof of concept is like a few hundred lines of code. It's definitely not complete because there are some limitations here. I made them intentionally, so it's simplified. But it's really simple to implement because we are using infrastructure that we don't have to maintain. It really simplifies things. Okay, but what are the limitations of this proof of concept? Well, the first one is that if we trigger a Lambda function as request response, so we are waiting for the response, we have the time limit of 30 seconds because in this case, AWS API Gateway is used internally. So we have the limit of our function invocation about 30 seconds. So that's the max in this case. But I used request response to just simplify things so the examples are more readable. It's possible to fix this problem easily by just using a Lambda invocation type event. So in this case, Lambda won't return any results for our runner. We'll have to extend it a bit. The only difference here is that we will need some result storage. So, for example, we can use a database like DynamoDB. And that's what I used. The only thing that is different here is that Lambda, after the execution of the test, will update the specific test case ID in our database. So runner will create data for every execution, will create this test execution states in DynamoDB database, and the Lambda function will update the specific one with the current state. If it passed, failed, it will post logs there. So we will have everything in the database. And in this case, the maximum execution time is 15 minutes. So it should be enough for any standard end-to-end test. Okay, but what about migration of current tests? Because we definitely have a lot of projects where we already have our tests, we have the infrastructure for them. Well, I migrated 3 different projects already for Lambda. So it was Selenium with Python, it was Selenium with Node, and also it was Testcafe with Node. And it was quite similar in all of these cases, because basically the only thing that we actually need there is the ability to run just specific tests. So we need, for example, some tags functionality. We have to tag every specific test, so we can pass to our runner that we want to execute, for example, test case ID 1 or 2 or 3. So that's the only thing that we need, because we will just deploy all of our tests to the Lambda function, and we will trigger the specific one at specific instance. So that's the only thing that we really need. Everything else is dependent on specific solutions. So there were things that I had to adjust, for example, for Testcafe, because it's quite different in how it works. So it needed some different browser options, for example. But it's quite similar in most of the cases. We just need the ability to trigger one specific test case. And the rest is depending on the specific project. So, for example, I extended it with some repos that we needed, because we ran tested Jenkins earlier, so I integrated it, for example, with Jenkins. So the runner was run there, it triggered Lambda functions, and it was returned, and the results were returned to the runner through the DynamoDB database. So, for example, we had a DynamoDB database for test result storage, we had S3 bucket for artifact storage, so we were able to upload any, for example, images or logs from Lambda function to some external storage. And it's really dependent on the project what you also need there. So I would also say, I think that cloud is really powerful, because it enables us to do things that weren't possible before, or at least it makes a lot of things way easier to implement. Because if you know how to implement things like that, it's like a few hours to start. I think it's really powerful. And I also think that we have to think more about DevOps as a methodology. I mean, this original meaning of this word, cooperation of a team. So DevOps is not some person that is working on infrastructure. DevOps is a methodology where the whole team is cooperating to create something that's way better than if it would be created separately. So that would be all. Do you have any questions?
Yeah, thank you for your speech. So actually, I did pretty similar stuff. And so you're mentioning that you can trigger actually with the event, the Lambda can be triggered with the event. So, and this means you need the SQS queue or something, right? And you also mentioned that you need a database for that, for storing results. So isn't it like too complex to isn't it like a infrastructure becoming super complex to run that, or it's worth it? I mean, how to you actually manage all that stuff with the event queues and so on? Yeah, thank you.
Yeah, so I have a whole infrastructure described in the serverless YAML file. So I not only have the definition of the specific function, but I also have the DynamoDB there. That's the only thing that's really needed, because I haven't used any queue services. That's just a database for storage. It's possible to get only changes from the DynamoDB database, so it can be used to easily track the differences. And also, it's really useful to have this log results somewhere that's, for example, in the storage. And because it's, again, serverless services, I mean, it's possible to use DynamoDB without caring about infrastructure. So it's auto-scaling internally. We are just thinking about specific requests. Then I think it's really simplified, because we just need the Lambda function and, in this case, DynamoDB. That's the only thing that were really needed. I extended it because we had some additional requirements. So I, for example, used S3 for artifact storage, but it's not really that needed. I mean, it was useful for us. We can also extend it with other services if we need, but the base is just the Lambda and DynamoDB in this case.
Yeah, and the one more question that has just come up. So you're mentioning that the migration is pretty easy, but I met the problem with the preconditions and the post conditions. So for example, in your project, you have something like before all, or like before on the test starts, you're doing something. So I met the problem that when you're running all your test runner on the Lambda, you actually get executed, all these preconditions will be get executed like 500 times or 1,000 times. And so how do you handle that? Or you just rewrite all these preconditions, post-conditions?
Yeah, that's really dependent on the specific test set. And because we thought about parallel execution earlier when we developed our tests already, so we don't have any dependencies. But it's possible to implement it on the runner side. So that, for example, to choose which test should be executed in parallel and what order, if the order should be kept there. So it's possible to also implement this one on the runner side. Because the solution I showed here is really simplified. I mean, it wasn't possible to show something production ready. But for example, I extended this concept in many different ways. So for example, we have features that we needed, like ramp up and the test startup. So the infrastructure is able to scale up during the test execution. Or for example, the limit of concurrent functions, because not all of the environments are that powerful that can handle like hundreds of tests. So again, there's some functionality at the runner side that was useful. So it's all about extending it to meet the specific needs. This is really simplified one.
Thank you.
Yeah, thank you for your speech. Just a question about how reliable this cloud is, and from your experience.
Could you repeat?
Because sometimes thank you for your speech, first of all, and second, how reliable this cloud is. Because sometimes even Azure is struggling.
Yeah, that's why I used AWS, because I have experience with it and I haven't got any problems related to infrastructure part at least. I've got only one problem with migration from Python 3.7 to 3.8 because they replaced the Linux distribution that's used at Lambda. So earlier it was AWS Linux 1, then it's the version 2. And the difference is that they removed some libraries that were already available at the Lambda function. And these dependencies were needed to actually start a browser. So it was a bit complex to also handle these dependencies because of the area problem. It was too heavy to fit in the function. But now I'm just compressing it, putting also system-side libraries there to the deployment package, and then I decompose it in runtime, and it's working. And that's basically the only problem related to infrastructure. It's more about migration of different versions here. But I haven't got any stability issues. So we are using it at production already. We have like in the project like 100 concurrent tests because that's our whole set. I also used it in different cases. So this proof of concept was like 500 tests, also without any stability issues. So it's quite stable.
Okay, thank you.
Hi, thank you for your speech. And what about application under test? It feels like this approach leads to this application being extremely overloaded during that 30 seconds. And it requires some like additional, like, I don't know, investment in your infrastructure.
Yeah, so we have the scalable architecture for our applications, so that's not a problem for application to scale. And the only thing is that I had to implement this additional features so we can limit the number of concurrent lambdas for specific environment. So for example, if we want to test some local environment, then we can, or we have to limit it somehow, for example, to 50 concurrent tests. And there weren't any changes on the application infrastructure here because it just scales up. The only thing is that sometimes the first test will execute a bit slower because infrastructure have to scale up.
Okay, so your code looks generic enough, so you actually can use it for multiple test frameworks, etc. Did you try to put it in a library, or maybe such libraries already exist on the market? Did you do some research on that?
Yeah, so it's possible to extend it this way. I mean, I just implemented the runner to show the specific example because it's more readable this way. But it's possible to extend, for example, any existing test runner. I thought about extending, for example, PyTest to include this part there. So we'll just use the standard library or runner directly, and it will trigger functions underneath. So that's the idea to extend it, but it's really dependent on the specific case. This is just the example how it can be implemented.
Okay, thanks.
Thank you very much for interesting speech. My question is about the 17 cents that you mentioned as the cost. So the first thing, this 17 cents is for your real case that you are solving, or for just the code that you showed us on the presentation, because that was not clear for me.
Yeah, it's, for the example set I showed, so I shown 500 Selenium tests. Every of them lasts about 20 seconds. Mm-hmm. So yes, for the specific test set. In real life, it's quite similar because we have about 100 tests, but they are a bit longer, so that's quite similar for that.
Yeah, but there is additional cost because you have to scale your application up on the testing environment in order to provide capabilities to be able to service that many requests.
Yeah, but in real life we have like 100 tests in our project currently. So we are only running, depending on the environment, from 50 to 100 concurrent functions to run it. So we don't really have to scale it up.
Okay.
It would scale up if it's needed, but it's not needed in the standard case.
Okay, you do not reach the limit of your current environment, if I'm not mistaken. You have the testing environment and you are using this solution and it doesn't cause any problems. You don't have to scale it up just for the solution that you present. Okay.
Yeah, it's really dependent on the specific case, but we don't have to scale it up.
Mm-hmm.
Yeah, so it's working on the standard environment that we had earlier. I mean, we have it scalable, but we are at the lower limits here, so that's not a problem in our case.
Okay, so another track of questions from my point is that usually in CI process, I start the testing in containers, which makes them all completely independent. And it looks like your tests are running for a concrete environment that is used by all of them, yeah?
It's really dependent on the case because it's possible to parameterize it to pass the specific, for example, environment settings that specific tests should be executed at specific environment. And that's what I used in all of the previous projects. So every time we create a pull request, separate environment is created just for the test of this environment. So we can then point it up to the specific one. So it's really dependent on the architecture.
Okay, thank you very much.
Okay.
That's all. Thank you for your speech.